Hello and welcome. In this video, we are going to revise the topic coordinate geometry. Even though the coordinate geometry topic contains the two important topic which has to be revised is the distance formula and its application, section formula and its application. In the first session, we will be learning the distance formula and its application. Even though the distance formula is x2 minus x1 whole square plus y2 minus y1 whole square under the square root, the application of distance formula is a little wider. Let us go and find it out what are all the different topics which the distance formula covers, and with one example on each topic we will revise this chapter. Now let us start with the simplest form of application of distance formula. Find the distance between the points A 7, 13 and B 10, 9. First, let us list it out. What is x1, y1, x2, y2? x1 is equal to 7, y1 is equal to 13, x2 is equal to 10 and y2 is equal to 9. After listing it out, what is x1, y1 and x2, y2? Let us write the formula. AB is equal to x2 minus x1 whole square plus y2 minus y1 whole square under the square root. Now let us substitute the values of x1 y1 and x2 y2 in the given formula and let us derive at the answer. That is equal to 10 minus 7 whole square plus 9 minus 13 whole square under the square root. So that is equal to 3 whole square plus 4 minus 4 whole square under the square root. That is equal to square root of 9 plus 16. That is equal to square root of 25 and that is 5. Therefore, AB is equal to 5. So, I repeat once again. Once we get the two coordinates, we'll note it down what is x1, y1, x2, y2. Then we'll write the formula. And after writing the formula, let us substitute the values in the formula and arrive at the answer. Hello and welcome. Find the value of y for which the distance between the points A 3, minus 1 and B 11, y is at 10 units. Let us observe this type of sum. The two coordinates have been given. The distance between the two coordinates has been given. And the very important thing is one of the coordinates contains a variable whose value we have to find it out. So, the 2 points A 3, minus 1 and the B 11, y, the distance between the 2 points AB is given as 10 units. So, the coordinate B contains the variable y which has to be found. Let us list out the values of x1, y1, x2, y2. x1 is equal to 3, y1 is equal to minus 1, x2 is equal to 11, y2 is equal to y. Now, x2 minus x1 whole square plus y2 minus y1 whole square is equal to 10 square. So since the distance between A and B has been given as a 10 units, and as we are not writing the square root symbol, we square on both the sides. Let us substitute the values here. So it is 11 minus 3 whole square plus y minus of minus 1, it is a plus 1 whole square is equal to 10 square. It is a 8 square plus y plus 1 whole square is equal to 10 square. 64 plus y plus 1 whole square is equal to 100. Now y plus 1 whole square is equal to 100 minus 64, that is equal to 36. Let us take the square root on both the sides. We will get y plus 1 is equal to plus or minus 6. Hence, y plus 1 can be 6 or y plus 1 can be minus 6. So, y is equal to 6 minus 1, y is equal to 5, or y plus 1 is equal to minus 6, y is equal to minus 6 minus 1, y is equal to minus 7. Therefore, y can be 5 or minus 7. The only thing that we have to note it down here is the distance have been given and one of the coordinates contains the variable whose value we have to find it out. Now let us see another type of sum which makes use of the distance formula. Find the relation between x and y such that the point P x comma y is equidistant from the points A 1 comma 4, B minus 1 comma 2. Let us analyze what are all the given things here. The 2 points are given A and B, and there is one more point P x comma y has been given, but they are using a keyword which we have to note down is the point P x comma y is equidistant from the two given points A and B. That is, if I am going to take the point x comma y somewhere in the coordinate system, and A it is 1 comma 4 and B minus 2 comma 1 comma 2, then this PA is equal to PB. So that is the very important concept that you have to understand. That is a PA is equal to PB. In other words, P is equidistant from the two given points A and B. So PA is equal to PB, which implies it is a PA square is equal to PB square. In other words, we can write x2 minus x1 whole square plus y2 minus y1 whole square, and this part between P and A is equal to x2 minus x1 whole square plus y2 minus y1 whole square, and our right hand side is for the 2 points P and B. So let us substitute those values over here. It is 1 minus x whole square plus 4 minus y whole square is equal to minus 1 minus x whole square plus 2 minus y whole square. So this is the PA square, our left hand side, and our right hand side is a PB square. Let us expand. A square plus b square minus 2ab, a square plus b square minus 2ab, and when you go for it is a plus b whole square, so a square plus b square plus 2ab. Here it is a square minus 2ab plus b square. Now the like terms gets cancelled. X square, y square and y square. Let us collect all the variables to one side and all the constant to the other side. You have got minus 2x minus 8y minus 2x plus 4y is equal to, it is 1 plus 4, 5 minus 17. So minus 2x we get minus 4x, minus 8y plus 4y we get minus 4y is equal to minus 12. It is a minus of 4x plus 4y is equal to minus 12. Minus minus we get cancel. We can take the 4 common out. We can write as 4 into x plus y is equal to 12, or x plus y is equal to 12 by 4, that is equal to 3. Therefore, x plus y is equal to 3 is the relation between x and y. Welcome to another session of learning. Find the point on x-axis which is equidistant from the points 5, minus 2 and minus 3, 2. The 2 points have been given. A point on x-axis is the keyword which has been given. A point on any point on the x-axis is of the form x, 0. So let us take this point as P. I repeat once again, any point on the x-axis is of the form x, 0. Now we have 2 other points, A 5, minus 2 and B it is a minus 3, 2, which are equidistant from the point on x-axis. In other words, it is a PA is equal to PB. In other words, it is a PA square is equal to PB square. Let us proceed. So PA is equal to PB, which implies PA square is equal to PB square. First, let us write the left hand side in terms of P and A. So it is a x2 minus x1 whole square plus y2 minus y1 whole square. In other words, it is x minus 5 whole square plus 0 plus 2 whole square, that is equal to, let us write the right hand side in terms of P and B, x2 minus x1 whole square plus y2 minus y1 whole square, that is x plus 3 whole square plus 0 minus 2 whole square. So x square minus 10x plus 25 plus 4 is equal to x square plus 6x plus 9 plus 4, you are getting it. So x square gets cancelled. You have got minus 10x minus 6x is equal to 9 plus 4, it is a 13 minus 29. So it is a minus 16x is equal to minus 16. It is x is equal to 16 by 16. You get the value as 1, and hence the point on x-axis is P1, 0. Another sum which is related to the same type of sum is, the questions will be given like this. The point on y-axis which is equidistant from the two given points. Any point on the y-axis is of the form 0, y. So you have to assume as a point P 0, y, and you have to proceed in the same manner as we have proceeded in the previous sum. That is PA is equal to PB, or PA square is equal to PB square. Now let us learn to prove the properties of various type of quadrilaterals using a distance formula. Show that the points 1, 1, minus 1, 5, 7, 9 and 9, 5 taken in that order are the vertices of a rectangle. Let us draw a diagram of a rectangle and name them as A, B, C, D. A is 1, 1, B is minus 1, 5, C is 7, 9 and D is 9, 5. After noting down the vertices, let us use the distance formula and find the lengths of AB, BC, CD and DA. We will go for AB square, that is x2 minus x1 whole square plus y2 minus y1 whole square, minus 1 whole square plus 5 minus 1 whole square, that is equal to minus 2 whole square plus 4 whole square, that is equal to 4 plus 16, that is equal to 20. Therefore, AB is equal to, under the square root of 20, that is equal to square root of 4 into 5. We can write this one as a 2 root 5. Similarly, let us find the length of BC. So, BC square is equal to 7 plus 1 whole square plus 9 minus 5 whole square, that is equal to 8 square plus 4 square, that is equal to 64 plus 16, that is equal to 80. And therefore we write BC is equal to square root of 80, which can be written as square root of 16 5s, and we write it as a 4 root 5. Let us find the distance C and D. So CD square is equal to 9 minus 7 whole square plus 5 minus 9 whole square. So that is equal to 2 square plus minus 4 whole square, that is equal to 4 plus 16, that is equal to 20. Therefore, CD is equal to square root of 20. We write it as a 4 5s. This can be written as 2 root 5. Now let us find the distance between A and D. So we write AD square is equal to 1 minus 9 whole square plus 1 minus 5 whole square, that is equal to minus 8 whole square plus minus 4 whole square, that is equal to 64 plus 16, that is equal to 80. Now AD is equal to square root of 80, that is equal to square root of 16 into 5. We write 4 root 5. Now we have found the 4 sides, the lengths of the 4 sides. For proving to be a rectangle, we need 2 more measurements, namely the lengths of the diagonals AC and BD. Now let us find it out that. So we go for AC square. So AC square is equal to, it is 7 minus 1 whole square plus 9 minus 1 whole square, that is equal to 6 square plus 8 square, that is equal to 36 plus 64, that is equal to 100. Therefore, AC is equal to square root of 100, that is equal to 10. Similarly, let us find the length of the other diagonal BD. So it is BD square is equal to 9 plus 1 whole square plus 5 minus 5 whole square, that is equal to 10 square plus 0, that is equal to 100. Therefore, BD is equal to square root of 100, that is equal to 10. Now, listen carefully, children. The four vertices we have to prove are the vertices of a rectangle. The condition for proving to be a rectangle is, the first is, the opposite sides of a quadrilateral should be equal, and the second one is, the lengths of the diagonal should be equal. So let us see that we have AB, its opposite side is a CD. The value of AB is a 2 root 5 and the value of CD is a 2 root 5. Similarly, for the side BC, the opposite side is AD. The BC value is 4 root 5 and the AD value is 4 root 5. And hence, the opposite sides are equal. In a quadrilateral, if the opposite sides are equal, it becomes a parallelogram. In a parallelogram, if the length of the diagonals are equal, it is a rectangle. And that is the reason we find the lengths of AC and BD. The AC is 10 and the length of the BD is 10. Since the diagonal length of the diagonals are also equal, it becomes a rectangle. A note for other types of quadrilaterals. Suppose they give you 4 vertices and they ask you to prove it is a parallelogram. Now same way, find out AB, BC, CD and DA with the given vertices and show that the opposite sides are equal. In other words, AB is equal to CD and BC is equal to AD. And that is the condition for a parallelogram. Suppose they ask you to prove the given 4 vertices are the vertices of a rhombus. Find out AB, BC, CD and AD. You will notice that all the 4 sides will be equal. In a quadrilateral, if all the 4 sides are equal, it becomes a rhombus. And hence, the condition to be proved is AB is equal to BC is equal to CD is equal to DA. And hence, the quadrilateral ABCD becomes a rhombus. And one more quadrilateral, the square. So how to prove the given vertices are a square? Same process as we have done it for the rectangle, you have to proceed. Find out AB, BC, CD and DA. If you find the length of these 4 sides you will notice that all the four sides will be equal. And hence you have to write it is a rhombus. But please don't stop there, because we have to prove it is a square. And hence we have to find the lengths of the diagonals AC and BD. You will notice that the lengths of AC and BD are also will be equal. In a rhombus, if the lengths of the diagonals are equal, it becomes a square, and that is a condition that you have to prove. Thank you for watching this video.